What if I told you that you can generate AI powered cartoon images locally on your own machine with no GPU, no internet, and zero cost using the same technology behind the stable diffusion? So, in this video, I will show you exactly how I did it with DreamShaper, a powerful SD 1.5 model optimized for low end CPUs, and explain why this is the best possible setup today. Hi everyone, welcome to Engineer Comrades. So in this video, I am going to show you how to generate AI images 100% locally using your CPU, no GPU and no internet required after the setup. We are using Stable Diffusion 1.5 DreamShaper plus a special LoRa to create cartoon style illustrations perfect for kids, stories or your YouTube content. So you can see on the screen these pictures are created on local machine using CPU, no GPU, no internet, nothing. You can see these three images and again I'll show a few more images to you and let's begin. So this will be our N8N configuration wherein we will be submitting a form. A form submission will be our trigger point in which we'll write the story, like tell a story about lion and a rat, or say turtle and a monkey, and then it goes to our basic LLM chain, and then it will go to our LLM model. It will generate five screens or say five scenes, and then we have scene splitter that is written in JavaScript function that will split our scenes in five different scenes, and then we'll loop over the items, and in between we will be sending out our prompts to our text to image node, which is nothing but SD 1.5 Stable Diffusion 1.5 with a special LoRa function. So first of all, understanding the model landscape, which diffusion model is best for local machine and why. You can say we have different models listed down here, starts from SD 1.5, SD 2.1 and goes till SDXL 1.0. You can see only SD 1.5 is capable to run on a CPU, which is the fastest one and the best choice for tiny machines like Raspberry Pi or ARM servers, old laptops, or even virtual machines. And the second thing, what is DreamShaper? DreamShaper is a fine-tuned stable version of Stable Diffusion 1.5. So Stable Diffusion is trained broadly on all kind of styles. And DreamShaper is fine-tuned to generate visual appealing illustrations and storytelling visuals right out of the box. So it's perfect for children's stories, mythology, fantasy, or animal tales. The last thing before we jump right into action is what is LoRa. See, the full name of LoRa is low rank adaptation. So it's actually changed the art style without retraining the whole model. So we don't need to train the whole model. Instead, we train a small lightweight add-on. This add-on teaches the model specific artistic styles like how to generate storybook Disney like cartoon art. So LoRa is nothing but a plug-in brain that changes the style without loading a new model. So let's start building our workflow. I have renamed the workflow as text to image. So first thing first, we'll add a trigger node in our workflow. So in this workflow, we'll use N8N form as a trigger node. Authentication will be none, and the form title I'll go with story prompt. Description we don't need, but yes, we do need a few elements. I'll add element and then we'll start adding the field names. So first will be field name would be story title we can put, or context. Then the element type would be text. Placeholder we can put like type your story prompt. We are done. Let's just click on execute step and put a story here like a deer and lion in the forest. This would be our story. Okay, we are done with the first node, that is trigger node. Now let's add a basic LLM chain. Okay, I will change it to define below, and then I'll put story title context as prompt for the basic LLM chain. So here you can see we have got a deer and lion in the forest as a prompt. One more thing that we have to add is the system prompt. So system prompt I will be putting in the description as well. You can get it from there. For now, I will be using the same prompt which I created earlier. You can also use the same prompt, but if you want, you can also modify it. So I will be using the same prompt that I had earlier. So in this prompt, we have just written that you are a children's storyteller and a visual writer. You have to create a 5 scene story in English about whatever context that we have given on form submission. Okay, and the story guidelines like children's storybook cartoon style, bright flat colors, clean outlines, lush natural background and all. And then we have given a strict output format as well that basic LLM chain should output. And there are some rules like every scene must be less than 60 words and keep it descriptive, visual and simple for AI image generation. And then I have provided a few short examples as well. Okay. So we are good with the basic LLM chain. So let's add a model. I have hosted Olama locally and I am running a few chat models here. You can see I have Llama 3.2 and Quen. I'll go with Quen. You may go with the Llama or any open source model that you might be running on your local host or local machine. If you don't know how to run Olama or serve Olama using open source chat model, just drop in comments and I'll create a video for you. Let's go back. We'll run this node. You can see node executed successfully. Let's check the output. What output we received. You can see we are getting in that same format that we had given in our system prompt. There are 5 scenes and the scenes description is below 60 words. So we are done till this basic LLM chain node, but the problem is we have all the scenes as an output. But what we do need is we need a separate image basis per scene. Like scene 1 will have a separate image, scene 2 will have a separate image. Then what we should do? We should split the output and send the per scene request to the next node. So for that, what we'll do, we'll create a special function here. You can type in function. And again, I'm not going to explain every line here, but I will be sharing the entire code with you so that you can use in your project as well. I'll simply copy it and will paste it. So I will give you a quick overview. So right now we are running a model that don't have the think tags like the DeepSeek model have it. The newer versions, the advanced version have the think tags in their output. So if you might be using any other model, then we need to remove those think tags. So for that, this is the code. And then next, we are filtering per scene and splitting the scenes by scene 1, scene 2, etc. Okay. And there is one more constant that we have, that is seed. Seed is nothing but a parameter which will pass to our SD 1.5 Stable Diffusion 1.5 architecture model to generate deterministic scenes, like the background would be same, the texture would be same, the way the pictures were created would be the same. So seed should be same across all the five scenes. So for that, what we are doing, we are creating a value from this method and putting it in the seed constant. Okay, and then there are few clean up things like remove new lines or double quotes, extra spaces, whatever cleaning that we have done. And now this function is returning these two values, scene text and seed. So these two will be passed next to our text to image generation node. Let's click on execute step 2 just to check the output, what all output it is giving. You can see we have five scenes and the seed is same across all the scenes. Okay, so till now we are done. I'll go back. Right now we have five items that we can send it to our stable diffusion node, but the problem is we can't send all those five scenes at the same time. For that, what we'll need? We'll need a loop over items, that node. Okay, I'll add loop over items. Okay, it'll split the request in batches. So I'll go with the batch size 1, and we are fine with the loop over node. Let's zoom it out a bit. You can see. So what it'll do, batch size is 1, so it'll loop each item. Like we have 5 item, so there will be 5 loop. Okay, and each loop, like each scene will go to our text to image node, and then will come back and then fetch the second scene that we have, and then again the same circle. So what we need to do is we need to, you can see here written as replace me. So actually what we need to do is we need, let's remove this line for now. So what we want to loop, done is a separate thing. So when we are done with all the iteration, then the final output will go to the done. So let's add a HTTP request node. So from here, our critical journey starts. So till now, what we have done, that we have started that flow with N8 and form submission, and then basic LLM chain, which is connected to our Olama chat model, is generating five scenes basis whatever story context that we have given to basic LLM chain, and then code in JavaScript node is actually splitting all those five scenes, and it is handing over all those five items to loop over items. So now loop over item will go through each item one by one. It will be handing over each item to our HTTP node, which is nothing but our DreamShaper node. I'll rename it as DreamShaper SD 1.5. I'll rename it. Okay. So now question is, where should we host our image generation model? So I will put in a different node altogether. I will put in a different container, wherein I'll start from a Ubuntu container and will install the different the models, and we'll be putting the LoRa model also inside that machine. So let's start. So now I am in my local Proxmox virtual environment, and I will create a container. You can do it on the same machine on which you have hosted your N8N or Olama chat model. I am doing it on a different machine because I have my home lab environment. But if you don't have, you can follow along and you can continue on the same machine as well. Okay, so we are in the container. Let's check the IP address. I'll put IP address. You can see this is the IP address. Okay, and now let's start installing things. So first of all, we'll create a directory. I'll put make directory image API and I'll go into image API, and then I'll create Python environment as well. So I'll put that as well here. It's Python 3 virtual environment and the name is virtual environment. You can see it is not installed. So first we need to install it. We'll go ahead and click on paste and it'll install the virtual environment for us. Let's wait for that. Okay, so we are done with it. Let's create our virtual environment and activate the virtual environment as well. You can see now we are in our virtual environment, Python virtual environment, and now we'll be installing our different required softwares. So what all we are installing is Fast API, UVCon, Diffuser, Transformers, Accelerate, Safe Tensors, Torch, and Pillow. Okay, I'll go ahead and install it all. I'll share all these commands in the description as well, from where you can pick it and you can use the same commands in your environment as well. Okay, so we are done with the installation of our diffusers, transformers, safe tensors, and the fast API. So now let's download the LoRa as well. So for that, I'll create a new directory, the LoRa folder here. And now, so let's download our low rank adapter, that is nothing but our LoRa style. So for that, we will download a safe tensor, that is JCartoon safe tensor. I will be sharing the URL with you also, but let me show how it looks like. So this is from Civit AI, and you can see the type. This is a type LoRa type, and then we have the base model as SD 1.5. It means it is compatible with our DreamShaper, because DreamShaper is built upon on Stable Diffusion 1.5 only, so it's stable. You can see the trigger word as well. So Disney style animated film or cartoon in prompt will trigger this LoRa. Okay, so what you have to do, you have to download this LoRa and you have to put it in this folder. So let's download it and put it here. You can see I have downloaded the safe tensors file in our LoRa folder. So let's back to our image folder. So now let's build the heart of this entire tutorial, which is our text to image endpoint. For that, we will create a Python script. I will name it as server.py. And again, I will be sharing my production code in the description. You can pick it from there, because it would be very tough to explain the entire code in this small tutorial. But it's not that tough. You can amend it as per your requirement. I'll walk you through the code a bit. Okay, so it's using diffusers library by Hugging Face. It is the official pipeline framework for running a stable diffusion, provides ready to use stable diffusion pipeline, handles all steps like text encoding, diffusion, image output. Okay, and actually, we are using Fast API. So Fast API is nothing but a modern Python framework to build high-speed performance APIs. It allows us to send prompts via HTTP and get images as response. So I will walk through the code. So first thing is loading the model. You can see the model name we have mentioned as DreamShaper 8, and the LoRa path that we downloaded, JCartoon, it's in opt image API, LoRa's, and JCartoon. Output directory, when it is done with the image creation, it will put the images in this directory. So it will print that loading a DreamShaper 8 model with LoRa support, and it will look for CUDA or CPU, whatever is available on our host. So now in this section, it will load our low rank adaptation. It will check for the LoRa file, the safe tensor file on the path. Okay. And next, from here, we are done with the loading of the model and applying the low rank adaptation. We need to create the generate endpoint. So in generate endpoint, what we have done is it accepts the JSON format and runs diffusion pipeline. Okay. And you can see the height and width. We have mentioned it that the number whatever we are putting as width or height should be divisible by 8 because it is required by the diffusion models. And then there are certain print prompts which will confirm that our image is created or not. And then this is the image pipeline, and then we are saving the image in our output directory. We are returning the image file in the binary mode to N8N for further processing. Let's check if it is working or not. I'll hit Control X and then Y. So now as we are done with our server.python script, let's activate the virtual environment. I'll put source virtual environment, then /bin, and then activate. Now the virtual environment is now activated. So now you can see we have started this server.py using this command python3-m and then uvcon, our fast API, then server app, and it is running on our local port 7860. So the first time we ran it, it is actually downloading the model. You can see it is downloading the diffusion model, and it is around 3.44 GB. Okay, so it will take some time. Let's wait and let it finish. It is run once kind of thing, wherein the command will go and will download the DreamShaper model. Yeah, so it took around 2 minutes to complete it, and now it's ready. So now our API is ready, and let's connect it in N8N on port 7860 using our HTTP request. So let's go to our N8N. So let's verify our IP first so that we can add this endpoint. So it's 1.25. I'll start that server again and we'll go back to our N8N console. Let it start and then we'll go there. Okay, so now we have to create a HTTP node on IP 192.168.1.25 and on port number 7860. Let's go there and quickly configure the last step. So now we are back in the N8N console and we'll configure our DreamShaper node. I'll put http colon whack 192.168.1.25 and the port number was 7860. I'll put 7860 and then our endpoint name, it's generate. Okay, Authentication will be none. We want to send body as JSON. We'll use JSON only. Okay. Now we have to put the prompt for our diffuser as well. Okay. So for that also we have a prompt wherein we will be sending the data to the diffuser model. So I'll just copy it from my demo instance. I will put it here. So this is the system prompt wherein masterpiece and high quality is the keyword actually that activates LoRA, our low rank adaptation. Okay, so these are the keywords, and then a scene prompt, and then our scene text, and then we have put some animated film cartoon, and then we have set up some negative prompt as well, like there should be no bad hands, bad anatomy, extra limbs and all. And in the very below you can see the height and width of the image and the steps, how many iteration the stable diffusion model should take to produce the image. So I am going with 27. You can go with somewhere around 30. And guidance scale actually gives the number, a number to our diffuser model, that how much the model should rely on the LoRa attached to it. Okay. And the seed value, I already have told you that seed value is nothing but it should be a number which should remain constant if we are looking for deterministic output, like similar background, similar kind of sketch, similar kind of drawing. So all the pictures should look like from a same story. And then binary is true, and the scene text we are getting from our previous node. So I will just hit close, and we are done with this node as well. Okay, so now it's time to test. And before that, sometimes it depends, like if you don't have a high configuration CPU, then it might take some time. So for that, what you can do is you can increase the timeout. So current timeout is pretty less. I will increase it to at least 15 minutes. Okay. Okay, we are done with this one as well. So it will generate the image. And now post generating the image, what is it should do? It should go over and loop our item. So it will run 5 times and will store the image in our output directory, as well as if we want to do something further on it, like post image creation. If you want to create something like a MP4 video out of it, wherein you want to put the audio as well as the video which will be created by these 5 images, you can go further with this thread. So that we will do in another video. For now, uh, let's execute it and let's see if it is working or not. So it is asking for a story prompt. I'll put a deer and a lion in a deep forest. Let's see how it goes. You can see now our local Olama chat model will generate 5 scenes out of whatever title or story context that we have filled in our form submission. And once it generates all the 5 scenes, then we will split it in every single scene for further processing using our JavaScript function. So let's wait till the time it gives us all the 5 scenes. Oh, sorry, we got an error problem in Node. It's because of the method we are using get, but actually it should be post. Sorry for that. We'll try again and we'll run this node once again. Now you can see it ran, and now we are generating a image. You can see what response or what's input it got. So a playful deer leaps through the lush green forest. Let's see what it generates. And just to confirm, we can also switch back to our server.py application that is running on our container, and we'll see how it looks like. So you can see it has already started generating the image. The steps, you remember, we had defined 27, scale is 7.5, size we have provided in the prompt, and there is a random seed. So for all 5 images, we'll have the similar seed. As I already have, or I only have assigned only 2 CPU to this container, so our output will take almost 14 minutes. But why it is taking so much time? Because I haven't provided much resources. It is running on CPU and with only with 2 cores. So that's why it will take around 13-14 minutes. So it depends on your size, what size we are creating, and the number of steps. So these two value actually matters, that how much time the node will take to generate one sample image. So let's wait and watch. Has been generated. Let's go back and let's see the image. You can see the image. It's quite good. So a playful deer leaps through the lush green forest. So with that, we are done with this tutorial. So you now have a fully local AI image generator that works on small machines using DreamShaper and LoRA. In the next video, I'll show you how to build a full AI video story creator. So that's it for the day. Please hit like and subscribe and stay tuned for next videos. Thanks for watching. Bye bye.